Hey everyone, we're going to look at Regents Review number 4 on dilations and similarity. We talked a little bit about dilations in number 3 when we talked about transformations. But again, when you're talking about a dilation, just remember if it is dealing with coordinates, you have k, which is the scale factor, and then you take the x and the y values and multiply them by that scale factor. So some of the things that we'll see in the questions, the first thing is that um, dilations cause parallel lines. So if you do have dilated figure, the lines that are dilated are going to be parallel to each other. They won't be the same length, but the angle measures are equal. But the sides are in proportion. So we will see questions where we set up proportions, because you'll have two figures of two triangles, for example, that will have all the same angles the same, but the sides won't be in proportion. So we'll be dealing with a couple examples like that, and we'll look at the first one, which is number 1. So they want us to find the length of AC. So I'm going to mark that as X. Again, like I talked about before, make sure you label your pictures. And in this case, it says for this one that we have, again, a pair of parallel sides, EB and DC, and they give us some measurements they actually labeled for us. So we want to find AC. So we're going to set a proportion. And in this case, I'm going to compare 9, which is part of that smaller triangle. And then I'm going to compare it to the length of the bigger triangle, which is 14. So I got this side right here. That's the first side I'm doing. And then I have the whole thing. So, and that's going to be 14 because it's 9 plus 5. Then I'm going to go to the other side. I'll erase that 14 just for now. And we got 9.2 over x. So like with a question like this, you'll want to do cross multiplying to help you find the x value. So I'm not going to give you the answer for that, but take it from there and see what you get. And again, just remember the answers should make sense. So if you have a bigger side on one, the other side should be bigger because they're in proportion to each other. Okay. So let's kind of move on from here. I'm going to go over to page 3. Question number 9. So now we got this is true. So we got similar, and again, that little symbol means the word similar. And it says which measurements are justified by the similarity. So pretty much what you want to do is go through and mark each of them and see which one is going to end up being true in this case. So I'm going to go through and label based on A. So I got AD is 3, AB, the whole thing is 6, AE is 4, and then AC is 12. So if I do, let's say I set it up and I do the two measurements in the small triangle. Say I do 3 over 4. And then I do the two measurements for the bigger triangle. Let's say I do 6. 6 would be proportional to 3. And 12. Now you want to check using the cross product test. And notice that when I multiply these, I get 24 equals 36. So like that's not true. So that means that if that's not true, then that answer can't be right. So that's what you want to do with this. You want to go through each answer. Okay. Now the last one we're going to look at is going to be number 11. And it says a triangle is dilated by a scale factor of 3. So they give us what k is, with the center dilation at the origin, which statement is true. Okay. So like in this case right now, The area of the image is 9 times the area of the original triangle. The perimeter is 9 times the perimeter of the original. The slope of any side of the image is 3 times the slope of the corresponding side of the original triangle. And the measure of each angle in the image is 3 times the measure of the corresponding angle at the original triangle. So like I talked about earlier, dilations do cause parallel lines, so that means they have equal slopes, so we can cross out C. The angles are all the same in the dilation, so we can cross out D. So now that leaves us with an area 9 times the size of the original area, or the perimeter. So what I'm going to do right now is I'm just going to draw an example. Let's say I drew a triangle, and let's say I made the triangle the base 3. Let's say I made that height, we'll call that height 2. Actually, I'm going to redraw it and make it a little bigger. I'll draw it over here on the center of the page. So let's say I did 3. And I'll call that height 2. So we got 1/2 times 3 times 2 for the area. So that would be 3 for the area. Using the formula from the sideboard, 1/2 base times height. Now if I do dilate it by 3, well in that case that means that each of the measurements is going to be multiplied by 3. So imagine making a bigger triangle now. I got 9, and then for the height I got 6. So we'd have 1/2 9 times 6. So in that case, 1/2 9 times 6 would be 54, and half of 54 is going to be 27. So the area for A would be 9 times the area of the original, because if you do 27 divided by 3, it's 9 times bigger. So that would mean A would be the answer for this one. Okay. So think about some of the properties we talked about. Like we talked about the area. In this case, that area was different, so you want to use the area formulas that we talked about before. You got parallel lines with dilations, sides that are proportional, so you'll be setting up some proportions. But the big thing is to make sure that you know that the angle measures are equal to each other.